Okay, welcome to the last of the common review videos. This is super critical, and it's just going to be a short video. I want to remind you to make sure that you're capable of analyzing particle diagrams in terms of what are called phase changes, or changes in state, changes in state. Phase changes means exactly the same thing. Anything that's going from a solid to a liquid to a gas. All right. And so here I'm representing the phase changes in terms of particle diagrams. And obviously for the solid, you can see that number one, they're sitting in the bottom of the container and there's no spaces between any of the particles. Um, and we shift to the liquid, and you can see the way this is now represented. The particles are all separated by a little bit of space. They're still sitting in the bottom of the container because liquids uh, do not, whoops, liquids do not expand into the container, right? They're not like a gas. So the material, due to its density and overall mass, is sitting in the bottom of the container. Remember, the kinetic energy is lowest for the solid. The liquid's going to have, like medium kinetic energy to keep things on a super simple level here, right? So the particles, they still have a density that's pretty close to where the liquid is, and the material is sitting in the bottom of the container, yet there are spaces between all of the liquids. This is going back to like a sixth grade definition of a liquid. And then typically the gas, the material is fully expanded into container. Make sure to watch out for that, because there's, when you inspect both the diagram for the liquid and the diagram for the gas, you can see the differences. They both of them have spaces between the particles, but the gas is fully expanded in the container, fully expanded into the container, and the gas is always going to have the highest level of kinetic energy by comparison um, to the other two options. And you could write this in math too. You could say that Ke for the solid is going to be less than Ke for the liquid, which is less than Ke for the gas. All right. So the gas is fully expanded into whatever container it's in. The liquid has spaces between the particles, but it's still going to be a fairly compact material. And then the solid is going to be the most compact with the lowest kinetic energy. All right. Okay, with that, I'm going to complete the video.